Hello there, this is Channel Mahendra Popat. We are discussing Geotechnical Engineering, Soil Consistency, video part 2. In previous part, we have seen Atterberg's limits or consistency limits of soil and then its relationships. Now let us discuss how to determine liquid limit and plastic limit. So, plastic limit test. Objective behind this test is to determine plastic limit of any soil sample. Plastic limit test is done with the reference of IS 2720 Part 5 1985. Let us see what apparatus are required to do this test. Porcelain evaporating dish about 120 mm diameter or a flat glass plate which is having size 450 mm cross 450 mm. Then ground glass plate about 200 mm to 150 mm. Metallic rod 3 mm diameter and 100 mm long. You need oven, spatula and 425 microns IS sieve. Let us see the procedure. Take about 120 grams of dry soil passing through the 425 micron IS sieve. Then mix the soil with the distilled water in an evaporating dish or on a glass plate to make it plastic enough to shape into a small ball. Remember that we have to make a small ball first. Then leave the plastic soil mass for some time for maturing. Take about 8 grams of plastic soil and roll it with fingers on a glass plate. When the diameter of the thread has decreased to 3 mm, the specimen is kneaded together and rolled out again. Continue the process until thread just crumbles at 3 mm diameter. We can see the picture here. There is a roll of 3 mm diameter, a cylindrical shape, or we can say thread of 3 mm diameter. Going further, collect the pieces of the crumbled soil thread in a moisture content container for water content determination. Repeat the procedure at least twice more with the fresh samples of plastic soil. The average water content of 3 soil samples will give plastic limit of soil. We know plastic limit is nothing but the water content at which the soil changes from plastic state to semi-solid state. So after doing 2 to 3 times this exercise, we will get plastic limit of that particular soil and there will be a water content. Okay, now let us go further. Liquid limit test. The objective of liquid limit test is in the laboratory we can find out liquid limit of any soil, and the liquid limit test is done with Casagrande liquid limit device. So this picture is showing Casagrande's liquid limit device. Let us go further. This test is done with reference of IS 2720 Part 5 1985. Let us check what apparatus are required for liquid limit test or LL test. Casagrande's liquid limit device. So the device which is in picture. Grooving tools of both standard tool and ASTM tool. So in this picture you can see one silver and one black tool are there. The silver tool is ASTM tool. According to American standards, this tool should be used, and this is standard tool for this experiment. We should keep both the tools handy. Next thing we require is oven, evaporating dish, spatula, 425 micron IS sieve, weighing balance which is having accuracy of 0.01 gram plus or minus, wash bottle containing distilled water, and desiccator. Desiccator is nothing but a device which can be sealed so that moisture of any soil can be retained in the device in the vessel only. Let us go to procedure. Take about 120 grams of dry soil passing through 425 micron IS sieve. Okay. Mix the sample thoroughly with distilled water in an evaporating dish or on the glass plate to form a uniform paste. Mixing should be continued for about 15 to 30 minutes till a uniform mix is obtained. Take a portion of the paste with the spatula and place it in the center of the cup. Center of the cup is like this. If this is a cup, this center. Fill the cup from the center so that it almost gets half filled. Level of the top surface of the wet soil with the spatula. When it is half filled, you should level this device, this Casagrande apparatus or Casagrande liquid limit device with spatula, so that it is parallel to the rubber base and maximum depth of soil is 1 centimeter. So maximum depth of soil should not be greater than 1 centimeter. Going further, cut a groove in the wet soil in the cup by using appropriate grooving tool. This word appropriate grooving tool means if you are dealing with clayey soil, you should use Casagrande tool, and if you are dealing with sandy soil, you should use ASTM tool. So accordingly, you will do a groove here like this in vertical direction. You will make a groove here. Then turn the handle of the apparatus at the rate of 2 revolutions per second until two parts of the soil come in contact with the bottom of the groove along a distance of 10 mm. This line means that when you fulfill this cup and clear it with spatula, level it with spatula, you should start moving it. By moving this knob, you will make this cup up and down by revolutions. So the rate of revolution should be 2 revolutions per second, and you should try and continue the revolutions, giving revolutions up to the point until the two parts of the soil which you had divided that come in contact with its base. Then record the number of blows to cause the groove close for approximate length of 10 mm. So there is a counter given in Casagrande's apparatus. By this counter screen, you will know that how many blows were done before the two parts joined each other from the base. Let us go further. Collect a representative slice of a soil from cup and put it in an airtight container. Determine water content of that sample. Remove the soil from the cup and mix it with the soil left earlier in the evaporating dish. Change the consistency of the mix by adding more water or leaving the soil paste to dry. Repeat the steps and note the number of blows for 3 to 4 trials. This point is trying to tell us that you should add or remove more water or less water according to your understanding, and by various water contents you should try 3 to 4 times the same test. As we discussed in plastic limit test, we should take 2 to 3 trials. It is recommended here we should take 3 to 4 trials. Then a plot can be made between the water content as ordinate and the number of blows on log scale as abscissa. So on natural ordinate axis there is number of blows, and on abscissa there is water content. You can plot this after 3 to 4 trials. The plot is approximately a straight line. The plot is known as flow curve. So the diagram is showing flow curve. In this you can see these small points. Those all points have come from trials, and by these points you can draw a line, and by that line you can decide the water content and their number of blows. In this example, liquid limit is 68% or water content at liquid limit is 68%. You can see the various range between 65 to 75% of water content. So this is how the liquid limit test is done. Moving forward, let us see by this experiment what we can derive. Flow index. Flow index is the slope of the flow curve. We have seen the flow curve. Now, how to decide the slope of the flow curve? There is a formula I and in suffix f, if is equal to w1 minus w2 upon log 10 n2 by n1. What does that mean? What is w1? W1 is water content corresponding to blows n1, and w2 is water content corresponding to blows at n2. So number of blows and their water content, number of blows and their water content. By this you can get slope, and this slope is known as flow index of the flow curve. Next is toughness index. The toughness index is defined as the ratio of plasticity index to the flow index. Toughness index of a soil is a measure of the shearing strength of the soil at that plastic limit. The toughness index of most soil lies between 0 to 3. A value of toughness index less than unity or less than 1 indicates that soil is friable at the plastic limit. Activity of soil is denoted by capital A. Activity of a soil is the ratio of plasticity index and the percentage of clay fraction. Basically we can understand that clay fraction will be lesser than 2 micron. So activity of soil, capital A is equal to IP by capital F, plasticity index, and F is clay fraction in percentages. Activity is the measure of water holding capacity of clays. The amount of water in a soil mass depends upon the type of clay mineral present in the soil. The changes in the volume of a clayey soil during swelling or shrinkage depend upon the activity. If activity of a soil is less than 0.75, the soil will be inactive. If activity of a soil is in between 0.75 to 1.25, the soil type will be normal, and if it is greater than 1.25, the soil will be active soil. The soils containing the clay mineral montmorillonite have very high activity. You can say generally activity of those are greater than 4. The soils containing the mineral kaolinite are least active, and their activity you can say that is generally below 1, whereas the soils containing the mineral ilmenite are moderately active and their activity are in range of 1 to 2. So I conclude my lecture here. From next property and numericals we will see in next video. Thank you.